All right, hey guys, I'm out again today. So today you're going to need your math book and probably not a calculator, your notebook and your earbuds, obviously, because you're watching this video. So let's go ahead and do this little warm up. You can just kind of go, if you find the pages that we were doing yesterday in your math book, you could just find like a blank page, or actually anywhere in your math book, you could write this down. So Demi has saved $20 already, and she earns $2 per day for an allowance. All right, Taylor has $35 saved already, and she earns $2 per day for an allowance. I want to know, after how many days are those girls going to have the same amount of money? So when will they have the exact same amount of money? And I want to know, how could you figure that out? So please pause the video and think about that question. All right, so hopefully you said that they will never have the same amount of money because they're each earning $2 per day. So if I was going to write an equation for Demi, she's earning $2 per day, plus she has that 20 already. Taylor, she's also earning $2 a day, but she started with 35. So they're earning the exact same amount, and she started with more, so they will never, ever have the same amount of money. Now, today we are going to work with some systems of equations that are kind of special like this. So if I graph these two lines, if I just kind of put y equals, we're going to see what happens on the graph, because we know they're never going to have the same amount of money. So I want to know, well, is there a solution to this? All right, so our learning goal for today is that we can graph a special systems of equations. All right, so let's go to page 323 and let's look at this first graph. So it says some systems of equations might look like this. So they graphed two systems. If you check them out, they could graph this one and this one. Does it look like those two lines will ever cross? Well, they do not. So if two lines never cross, we say that there's not a solution, no solution. And the reason for that is the lines are parallel. So they will never, never cross. Like they're just going to keep going like that forever. So they'll never cross. So if I come down below here, it says in the graph, there is no intersection point. So the system has no solution. Okay, so look at their equations. I just want you to kind of start looking at this to see what you notice. Do you notice anything about these two equations that is the same or different? All right, you might notice that their slopes are exactly the same. That's why if you look at the steepness of the lines, they have the same exact steepness. That's why they'll never cross. Their y-intercepts are different. They had different starting points, kind of like those girls with the money. They start at different spots, but their rate of change is the same. So they're never going to cross, and they'll have no solution. All right, so if we take a look at page 323, we're going to try one, okay? So first thing, again, you guys, I don't really love using these boxes, so you can go like over on the side or wherever you want. I have two equations, and it says, can you solve them by graphing and then check the solution? Okay, so if I look at these two, let's look at the first one. That one looks good. It says y equals 2/3 x plus 1. Okay, if I look at my second one, that one does not look good. So I want to rewrite that one. Okay, I guess we could use the little boxes here. So it starts like this. I like to draw my line down. Okay, you guys know, hey, I do not want anything over there with the y, so I need to get rid of this. To get rid of that, I'm going to add 2/3 x. If I add 2/3 x there, it cancels. Over here, I'm going to add 2/3 x. Okay, so now they rewrote it like this. And then finally, I'm going to rewrite it in good form. So I'm going to write y equals, I'm going to rearrange it, 2/3 x minus 3. Okay, now it's in slope-intercept form. So now I have my equation 1 and my equation 2. Now I'm going to graph them and see what happens. All right, so again, here are the two equations. They just kind of rewrote them. So why don't you pause and why don't you graph those two? All right, so the first equation, I need to start at 1. Okay, so let's put a dot at 1. And then the slope is 2/3, so that means up 2 to the right 3. So go up 2 to the right 3, put another dot. And then maybe I'll go backwards, down 2 to the right 3, put a dot. There is that first equation. All right, my second equation is this. I'm going to start at -3, 1, 2, 3. Okay, and again, the slope is 2/3, so I'm going to go up 2 over 3. So up 2 over 3, okay. Can't fit another one that way, so I'll go down 2, backwards 3. Okay, and here's my blue line. So I want to know, is there a solution to this system? So is there a point where they cross? Well, they do not intersect, so that means there is no solution. That means no time, those lines are never going to cross. There's no solution. So basically that means in these two equations, if I picked a point, there's no point that'll work in those. All right, so a way to kind of show that, this is a little confusing, but I'll go through it kind of quick. A way to kind of show that these are, that they'll never have a solution is they said, okay, let's just take this equation, okay, and let's rewrite that. It's actually in good form right now, but they said, okay, what if I rewrote it so it looked like the other one? So your other one looked like this. Y minus 2/3 x equals -3. So they said, like, what if I just rewrote that? So what if I moved this to the other side? Okay, because you can do whatever you want kind of to equation. Let's see what it says now. It says y minus 2/3 x equals, there's that 1. All right, now this just kind of proves it. I don't expect you to understand this completely, but look at these. It says, well, if I had some number and I took away 2/3 x, I got -3. And then it says, hey, if I have that same number and I took away 2/3 x, now I got 1. Well, that does not really make sense. So that's why there is no solution to that. All right, why don't we go to the page 325 and let's try the check. Okay, why don't you pause the video and try this out. What is the solution to this equation? All right, I'm going to start with the first one. I'm hoping that you rewrote this. So you drew your line down. You want to get the y by itself, so you added 2x. I add 2x. Okay, I get y equals, let's rearrange it, put your x first, positive 2x plus 4. There's my equation. I always like to box it. All right, now I'm going to graph it. I'll just graph it in pink. So I'll start at 4, and I'll go up 2 over 1. I can't really go up 2 over 1, so I'm going to go opposite. I'll go down 2, backwards 1, down 2, backwards 1, down 2, backwards 1. And just kind of keep doing that. All right, there's one of my lines. Okay, my other line is this one. It's y equals 2x plus 0. So that means I'm going to start at 0, or the origin, and I'm going to go up 2 over 1, up 2 over 1. And I'll go down 2, back 1, down 2, back 1. I'll kind of connect it. All right, and you guys may notice that those two lines are parallel. I kind of know that right away that they're parallel because look at their slopes. They both have slopes of 2. That means they're going up at the same steepness. So those two lines never cross, so there is no solution. That's what you write for the answer. Never cross, no solution. All right, there's one other special type of systems of equations, and that's on page 325. So let me kind of show you how that works. Okay, come over to the side, and I want you to write this equation. Y equals 3x plus 5. Okay, so if I look at that one, that's in good form. I'll start at 5. I'll put a dot here. Okay, I'll go up 3 over 1, put a dot. I'll go down 3, back 1. Okay, I'll just do that a couple times. All right, that one's graphed. All right, so let's look at the second equation that they gave me. I want you to write this one down. Negative 3x plus y equals 5. Okay, let's draw our line down. If I want to get that y by itself, I'm going to add 3x and add 3x. Okay. I end up with y equals, you guys know how to rearrange it, I'll put 3x plus 5. Now, right away you might look at these two and say, hey, those are really the exact same equation. They look exactly the same. So if I graph this blue one down here, it's going to end up in the same spot. Starts at 5, up 3 over 1. Okay, so this actually happens to be the same line. So they intersect like at a ton of points. If I was going to say, hey, are there some points, or some solutions to this? Yeah, you'd say there's one, there's one, there's one, there's one, here's one, here's one, here's one. There's ones like all over that line. So the lines intersect at multiple points. So this equation, or the systems of equations, we say that it has an infinite number of solutions. I kind of like to abbreviate number and use that symbol. So it has an infinite number of solutions because it's like one line right on top of itself. All right, if you go to page 326, let's look at one. So we have two equations. So I want you to think about first, what do you need to do first before you can actually start graphing those equations? Well, we'd probably need to rewrite them. All right, so if I look at the first one, that one looks good. Okay, I'm just going to kind of rewrite that over there. If I look at the second one, that one does not look good. Now, if you want to use these boxes here, you can. I don't really like using them. So I'm just going to come over here and do it. It says y minus 3 equals 2x minus 2. Okay, I'm going to draw my line down. I want to get this y by itself. So let's get rid of that minus 3 by adding 3 to both sides. Right, that side cancels. I end up with y equals, okay, I still have that 2x, and here a negative 2 plus 3, that's positive 1. All right, here is my new equation. So let's kind of think about this. My first one was y equals 2x plus 1. My second one is y equals 2x plus 1. They look to be the exact same. So right away, you should know, like, hey, that's one line, and then the other line is like right on top of it. So it's going to have a ton of solutions. So just to show you a couple of things, let's go graph it. So the equation again was y equals 2x plus 1. So let's come to 1, put a point. And then my slope is up 2 over 1. So up 2, always go to the right, over 1, up 2 over 1, up 2, over, down 2, back 1. Okay, now if I graph the other one, it's the exact same. So it would just be another line right on top of it. So now, obviously, the answer to this is there's an infinite number of solutions. That means there are like a ton of points that work on this. Now, it's not every point, because this point right here in green I drew way down here, that's not a solution because it's not on the lines. Or this point in pink up here, that's not a solution, it's not on the line. So could you name me a few solutions? I want you to do that over here. Could you name me a few that you think are solutions to this? Because there's a ton of them that work. All right, well, here's one right here. This is on the line, on both lines. So 0, 1, that would be a solution. Here's one right here. Looks like I went up 1, over, or over 1, up 1, 2, 3. So 1, 3, that's another solution. Here's one, -1, -1. So there's tons of points that work, not every single point, but any that are on the lines. So we say there is an infinite number of solutions. Okay, let's go ahead and check this one. On page 326, the check. It says solve the systems by graphing. All right, let's start with this one right here. This one's already kind of graphed for you, so it's kind of nice. Or it's written good for you. It's already in y equals mx plus b form. So I'm going to start at 1, right, my y-intercept, and my slope is -1/3. That means down 1 to the right 3. Okay, so I'm going to go down 1 to the right 3. There's my next point. Okay, if I want to go backwards, I'll go up 1, backwards 3. There's a point. Okay, and I'll connect it. All right, let's look at the other equation. It says y plus 1/3 x equals 1. Well, this does not look good yet. So let's get the y by itself. So I'm going to subtract 1/3 x, subtract 1/3 x. And we've been doing this, so you guys should feel pretty good about this part. Y equals, let's rearrange it, -1/3 x plus 1. Okay, now if you look at that, if I started to graph it, well, here's 1. Then I go down 1 over 3. Up 1, backwards 3. Looks like it's the same line right on top of the other one. So the answer to this is, what's the solution to this system? Well, there's lots of solutions. So we say there is an infinite number of solutions. That's what we would write down. Now, if I asked you to name one solution, I could say, okay, this point right here, that's 0, 1. That's a solution. Or this point right here, that's 3, 0. Those would be all solutions. I'm not going to have you check it. We'll do that Monday when I'm back. All right, so I do want you guys to write down what we learned today in your notebook so you have it. So if you guys can, you can close your math book, open your notebook, and I want you to write a title page, Special Systems of Equations. Okay. And then I'm going to have you make kind of 3 columns. Once you get that copied down. So, you know, you can draw kind of some lines here. And in the first column, write the word 1 solution. The second column, write no solutions. And the third column, write an infinite number of solutions. Okay, so I'll give you a second to write those down. Then we're just going to draw some sketches of some graphs of what they each look like. Now, obviously, you guys don't have graphs like I do, so you can just sketch your own XY axis. So if you were doing it, you could just kind of draw this. All right, so a system that has one solution is going to look like this. It's going to have two lines, and they're going to cross somewhere. Okay, well, I'll just put an example, like 2, 3. It has one answer. The lines cross in one spot. So again, it would look something like this, where the lines cross and they have one answer. Okay, so again, you draw a little sketch of a graph. You don't need all those lines like I have, but just like a quick little sketch. All right, no solution. You guys should be able to draw a graph that has no solution. Basically, it's two parallel lines. So they have to have like the exact same slope, and they will never meet. That has no solution. Now the infinite one is a little harder to draw a sketch of just because it's a line on top of itself. If you have like two different colors, that might help, but it's like a line and then the same line like right on top of itself. That's infinite solutions. Okay, I'm just going to put an example of an equation under each of them. So like a one solution one might look like this, like y equals 2x plus 4 and y equals 6x minus 2. Okay, those two systems you would graph, they would cross somewhere. A null solution example would be like this. Y equals, they have to have the same slope, so maybe like 2x, okay? But they start at different spots. So like plus 4 and plus 6. So they have different starting spots, but the same slopes. And then infinite number of solutions obviously has to be like the exact same equation. Like y equals 1/3 x plus 4 and y equals 1/3 x plus 4. Has to end up being the exact same. Now you might have to do a little work to rearrange it, but in the end, they are the exact same. So again, make sure you have that copied into your notes. All right, so by today, the end of today's video and the lessons that we did this week, hopefully you can rewrite an equation, you can graph some equations, you can find the solution to the system, you can check your solution, and you can tell me what does a no solution one look like and an infinite one look like. And we'll talk about this more Monday when I'm back. So now, here's what you're going to do. You should find a worksheet from the sub. It should be called 6-1 Day 3 Homework, Special Systems. You are going to be doing the front and back of that. So first thing you need to do is, if it looks like this, you need to rewrite the equation. Okay, you guys know how to do that. And then you need to graph, find where the lines cross. Some of them will cross. Some of them will not cross and be no solution, and some of them will be lines right on top of each other. There should be an answer key with the substitute teacher as well, and if you need my help, come onto the class kick and I can help you.